Hello everybody, very important lesson today. I can find the missing sides when an altitude is drawn to a right triangle using Hill SAS. So I call these Hill SAS problems, as do many other teachers. In order to utilize Hill SAS, you need to know what the different things represent in this diagram. So I see a big right triangle. In that big right triangle, these are my legs, and this whole thing is my hypotenuse, the long slanted side opposite the right angle. Now I have an altitude that's drawn. We talked about altitudes. It's a segment from a vertex that's perpendicular to the base, and that busts the hypotenuse into two segments. So I'm going to call these segs. So I'm going to do that one more time off to the side. I've got a right triangle. These are my legs. This whole thing's the hypotenuse. An altitude is drawn, which breaks the hypotenuse into two segments. So you need to know that vocabulary in order to do this lesson. So let's get right into it. AD is 3, CD is 6. It's asking me for DB. So you need to start recognizing this picture. This picture is an altitude that's drawn to a right triangle. Basically, it looks like a big hill. Like you would kind of climb up this big hill from this way, you kind of fall down. So Hill SAS looks like a hill. And when you see this picture, you need to know that it's going to be a Hill SAS problem. So there are two proportions. There's hills, that's H over L equals L over S. And there's SAS, S over A equals A over S. To determine which one you're using, if there is an L involved, I'm using hills. If there's an A involved, I'm using SAS. We don't go by the S or the H because the S's and the H's is the same thing. The S's make up the H, but the L and the A have nothing to do with each other. So to determine if it's going to be hills or SAS, if there's an L involved, we're using hills. If there's an A involved, we're using SAS. Sorry, I lost my train of thought. My son just came down here. So if there's an L involved, we're using hills. If there's an A involved, we're using SAS. So in this example, there are no L's involved, but there is an A involved. Since there's an A involved, I'm using SAS. So S are these pieces right here. So S is 3 over A is 6 equals A, again, is 6 over the other S, which is X. It's always the same thing in the bottom left and top right. For both hills and SAS, it's always the same value in the bottom left and top right. And that's it. I create, once I have my proportion, I cross multiply and solve. X is 12. Number 2, AC is 10, AD is 5. It's asking for AB. I know it's going to either be hills or SAS. To determine if it's hills or SAS, is there an L involved or an A involved? Well, in this example, there's an L involved, so I'm using hills. H over L equals L over S. Refer back to this diagram if you need to. H is this whole thing. L is the leg, and S is your segment right there. So H is X over L is 10 equals L, again, is 10. Now there's two S's, right? There's a left leg and a right leg. I'm sorry, a left seg and a right seg. If you're using the left leg, you use the left seg. If you were using the right leg, you would use the right seg. So because I'm using the left leg, I'm using the left seg, which is 5. H over L, L over S. Now that I have my proportion, I cross multiply and solve. And I get my answer. Let's take a look at number 3. AC is 6, AB is 9. I'm asking for AD. I recognize this picture as Hill SAS. I have to determine which one it is. So I'm going to determine if there's a leg involved or an altitude involved, an L or an A. There is an L involved, so I'm going to use Hills. H over L equals L over S. I'm going to give you about 30 to 45 seconds. I want you to try and set up your proportion and solve it. Take about 45 seconds. Try to do it on your own. Refer back to this picture if you need to. If you need more time, you can pause. H is 9, L is 6, L is 6, S, because I'm using the left leg, I'm using the left seg, is X. Again, if you're like, I don't know what H and L and S are, here it is. This is what H, L, and S are. You need to refer to this until you have it memorized. Cross multiply and solve. 9x equals 36. Divide by 9. X is 4. All right, let's take a look at number 4. Let's skip that one for now. Let's take a look at 5. AD is 3. DB is 27. It's asking for CD. I recognize this picture as Hill SAS. I want you to take about 10 seconds and determine if you think it's Hills or SAS. Decide, Hills or SAS. Since there's an altitude involved and there are no legs involved, I'm using SAS. S over A equals A over S. The two S's are each of the segments. So I want you to try and set it up, substitute in, and solve. I'll give you about 45 seconds to try this on your own from here. Okay, if you need more time, feel free to pause it. S is 3 over A is X equals A, again, is X over the other S, 27. Cross multiply and solve. 81 equals X times X is X squared. To get rid of a squared, I do the square root, and the square root of 81 is 9. I want you to try number 6 on your own. There is a twist, a big twist, which a lot of students usually mess up on. I'm not going to give you wait time right now. Please just pause the video, try number 6 on your own, and then unpause. So again, pause the video now, complete the problem, then unpause. Okay, now that you completed number 6 on your own, I will go over it together. There is a big twist. AD is 2, AB is 18. It's asking for BC. I recognize this picture as Hill SAS. To determine if it's Hill SAS, is there a leg involved or an altitude involved? There is a leg involved. There is not an altitude involved, so I'm using Hills. H, the hypotenuse is this whole thing. H in this example is 18 over L. L is X equals L. L is X over S. Now here's the twist. If I'm using the right leg, then I'm using the right seg. Sorry, I had to pause it. My son came down. So let me just go back to that. If I'm using the right leg, then I'm using the right seg. The right seg is not 2. The right seg is 18 minus 2, which is 16. So you have to make sure if you're using the right leg to use the right seg, if you're using the left leg to use the left seg, and you may have to add or subtract in order to find pieces. So from here we cross multiply and solve. X times x is x squared. 18 times 16, you can use your calculator if you need to. It's 288. Square root of both sides. It's asking for BC to the nearest tenth. So when you put radical 288 to the calculator, you get 17.0. Okay, I want you to try I want you to try 8 and 9 on your own right now. So please pause, complete 8 and 9, and then unpause. Okay, so at this point, everyone should have done 8 and 9 on their own. So let's go over it quick. I see my Hill SAS picture. So I need to determine if it's Hills or SAS. I'm going to put my information into the picture. IN, this whole thing is 10. DN is 5. It's asking for EN. So is there an L involved or an A involved? That's my L. My A is blank. So it's Hills. H over L equals L over S. H is this whole thing. It's kind of on its side. You might want to turn your head a little bit. Your L is 5. Your L again is 5. It's always the same thing in the bottom left and top right. If I'm using this leg, I use this seg, which is x. Cross multiply and solve. 10x equals 5 and 5 is 25. Divide by 10. X equals 2.5. And that's your answer. En is 2.5. And I also asked you to do number 9. If you didn't already, please pause and go over it now. It's asking for AD. I recognize this picture as Hills SAS. Is there an L involved or an A involved? There is an L involved. So again, I'm using Hills. H over L equals L over S. H is 36. L is 12. L is 12. S is X. I cross multiply and solve. X is 4. All right, one more thing I want to go over with you. If there is no picture, actually 2 more things I want to go over with you. If there is no picture, we have to draw our own. So right triangle ABC, altitude CD is drawn to hypotenuse AB. So, because I have an altitude drawn in a right triangle, I know it's going to be my Hill SAS picture. Let's look for clues. It says that the hypotenuse is AB. So I'm going to label A and B, and it doesn't matter where you put A and B. If you flip them, that will be fine, but those two values have to be A and B, which would make C up here. Altitude CD is drawn, so I'm going to draw an altitude. There's CD. And now that I have my picture, it's the same thing we've been doing. So I'm going to give you, why don't you pause it, finish number 10 from here, and then I'll go over it. So at this point, you should have done number 10 on your own. I'm going to go over it now. AD is 3, DB is 12. It's asking for CD. I recognize this picture as Hill SAS. To determine if it's hills or SAS, is there a leg involved or an altitude involved? There's an altitude involved, so it's SAS. S over A equals A over S. S is 3, A is X, A is X. Always the same thing in the bottom left and top right. S is 12. Cross multiply and solve. To get rid of the squared, I do the square root. X is 6. So number 11 is the same type of thing where you're going to have to draw your own picture. So I used clues. Since AB was the hypotenuse, I knew that these had to be A and B, which made this C. Altitude CD, so I drew the altitude and I put the D there. Once I had my picture, it was pretty straightforward. One more type of question to go over. Number 12. QW is 8 and Q is 16. It's asking for WR. I recognize this picture as Hills SAS. To determine if it's Hills or SAS, is there an L involved or an A involved? Well, in this example, there's both. I have an L involved and I have an A involved. So this becomes a challenging question. Because there's an L involved and an A involved, I'm going to have to do both. So it's going to be a two-part question. Which one do I do first? I do whichever one I can do. In order to find X, I'm going to have to do SAS. But right now, do I have enough information to do SAS? No, I don't know what the segments are. I don't know what the altitude is. I can't do SAS right now. I can do hills. It's not going to help me find exactly what I'm looking for, but it'll help me find something. And once I find that something, I'll be able to proceed from there. So I'm going to start with hills. Because I can. Because H I have is 16. L is 8. L is 8. Now S would be RQ right here, so I'm going to call that Y. It's not what the question's asking for, but it's something that I can find. And once I find that, that'll probably help me in the next step. So I cross multiply and solve. 16y equals 64. Divide by 16, y is 4. Now, if that's 4 and this whole thing is 16, then NR must be 16 minus 4, which is 12. Now that I have that, I have enough information to do SAS. So now, I'm going to do S over A equals A over S. 12 over X equals X over the other segment, 4. I cross multiply and solve. X squared equals 48. Square root. it wants the answer to the nearest tenth. So I can go to my calculator and I can type in the square root of 48. Second radical, 48. And to the nearest tenth, I get 6.9. And that's your answer. Number 13 is the same type of thing. I'm not going to go over it in the video. You have it on the answer case. I want you to try it on your own. And that's it. I know, a little bit of a long lesson. Another very, very important lesson. Every Regents, they ask a question on this, and we're going to be doing more with this over the next few days. We're going to be practicing this in candy corn problems and adding some more twists to it. But when you see this picture, you need to recognize it as a Hill SAS question. If there's an L involved, you're using Hills. If there's an A involved, you're using SAS. Once you know what proportion you're doing, you're just going to substitute right in. There's an example of SAS. There's an example of Hills. If they don't give you a picture, you need to draw your own picture by using the clues in the problem. And if they give you an L and an A, you're going to probably have to do both. You start with whichever one you can do, and then you're going to use that answer to do the other. Your classwork/homework is to finish this and use the key to refer to if you need to. Again, a very important lesson, and we're going to continue doing more with Hill SAS and candy corn problems over the next few days. Have a great day.